Hello students, today we are going to discuss in this video about the indefinite integrations, how this is the inverse process of differentiation and what are the various methods for finding the integrations, certain important theorems which are going to be used. So in this short video we are going to discuss. So let's see that. Okay, so let's see what is indefinite integrals. First of all, I would like to correlate this indefinite integrals with the knowledge of your derivatives, because you know that if any function fx is given and whose derivative you are calculating as f dash x, okay, so that f dash x was going to be giving you one of the function. Suppose that function is your capital fx. So this capital fx is known as the derivative of this small fx, right? So one procedure which can make this function into this small fx in such that we do some operation that this capital fx again gives this small fx. So that procedure is known as the process of anti-differentiation, or you can say which we represent as this form to get the antiderivative of this capital fx, and this gives us small fx, and this process of calculating anti-differentiation or finding the antiderivative is also known as integration. And since here we have no any limit given from which point to which point we are integrating, so that's why it is indefinite. Indefinite means where there is no any finite boundaries given to us. If on the same some boundaries will be given, and here the upper limit, lower limit will be indicated on these integrations, so then this integral will be called definite integrals. Okay, so what the integral means? Simply antiderivative, and which you have already learned how to find out the derivative. So by using those pattern we can find out the antiderivative also. For example, you know that the sin x derivative you are calculating as cos x, right? So if I am asking that what will be antiderivative of this cos x, that means which we represent in this way. So antiderivative of this cos x, or you can say that integral of cos x is going to give you sin x. Okay, and after integrating we add plus c also. The reason is that in case if some constant is there, so those constants are also going to be eliminated due to the derivative. For example, if in place of this sin x, if it was given 1 plus sin x, then also your derivative is going to be cos x only, right? So that means all such functions which are giving the derivative as cos x, their antiderivative will not be one single function. This will be a family of curve, and that will be represented by not only that function, there will be some constant part added as c. So why we add this c? It will be more clear when I discuss it geometrically by taking a suitable example. So if we take the example of a function fx is equal to x square, so you know that derivative of this fx will be 2x. Similarly, if the function is giving one more function gx, which is suppose x square plus 1, so whose derivative, that means g dash x, is going to be 2x again, or any other function, suppose hx, which is x square minus 3, so whose derivative h dash x is going to be your 2x. You can see that I have taken three different functions, fx, gx, hx. All three are geometrically a parabola, and but their derivative is same, 2x, 2x, 2x. If geometrically I represent all these three functions, so since all the three are representing the parabolic curve, so x square is a parabola which is passing from origin like this. It is your x square. X square plus 1 is simply, you can say, passing from here 0, 1. Okay, this is your x square plus 1. X square minus 3, that curve hx is going to be passed from minus 3, 0, minus 3, that means it is passing from here. Okay, so all these three curves geometrically I have represented, and not only these three, there are infinite such parabola symmetric to this particular axis, and their family of those curves will have the same derivative 2x 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 only, whatever the number as constant plus 1 minus 3 is added with that, but their basic structure is going to be same. So their all such family of curve will have same derivative as 2x. So since we are saying that integral is a process, means to get the antiderivative from the given derivative. So if from this derivative 2x, if I integrate this 2x, so can we get all these functions? If answer is yes, so then how? So if we find out the integral of 2x, where 2 can be taken out as a constant, so integration of x dx, since we know the integration formula of x power n dx as x power n plus 1 upon n plus 1, by that way you will be getting here 2 times x power 2 upon 2, here 2 get cancelled, and that will give you x square. But here I am getting the integral as x square for this 2x, but 2x is not the derivative of this function alone for x square. There are many more functions whose derivative is 2x only. So how this function which is coming, it can represent all the families of curve for which derivative is 2x. So that's why we add c. That c means that arbitrary constant which can represent all the parabola whose derivative is 2x. That means for antiderivative of 2x, we will not get only x square, it will be x square plus c, so that it can represent entire family of those curves whose derivative is this 2x. So similarly, whenever we integrate anything, so at the process of integration, after that we have to attach this constant c, where c is any arbitrary constant which will be representing all those family of curves for which that derivative is defined. Okay. Since we are taking integration as an inverse process of differentiations, so we can see some of the example. For example, the basic example which you are already aware, that you know that the derivative of tan x you know as sec square x. So whenever integration for sec square function will come, so integration of sec square x will be written as tan x, and plus c we add to represent all those family of curves which are having the derivative as sec square x. Similarly, you know that d by dx of e power x as e power x only, so we get the integration of e power x as e power x and plus c. Similarly, so many derivatives which you have learned. For example, d by dx of x power n, which we get as x power n plus 1 upon n plus 1. So whenever any such expression will come where you have x power n plus 1 upon n plus 1, so it is going to give you x power n and plus c. Okay, so all the derivatives which you have learned up to now, their antiderivative is very easy to find out if you see that pattern is obtained into that. So one or two more example I can see that. For example, you know that the derivative of log x, you know that as 1 upon x. So whenever integration of 1 upon x will come, so it will be represented as log x, where x must be positive, or you can keep it in the modulus in this form, and plus c. So this way there are so many derivatives which are clear to you from the differentiation. Their anti-derivative finding is very easy, as we know that integration is an inverse process of differentiation. Now I am going to discuss some important theorems. With the help of those, we can find the integration easily. So certain rules are there as a theorem, they are given to us. With the application of that, we can find out the integrations of various given functions. So let's see that first theorem which you have been given as the process of differentiation and integration of inverse of each other, which we have just discussed already. Then we have also seen that the two different means functions integral can be equal also. That means two indefinite integrals, if they are having same derivative, so they can give you the various family of curves which are equivalent, which I have geometrically discussed just now with the help of parabola. Okay, so one more important theorem is that, which is if any constant scalar quantity is multiplied with any function, and then you have to find out the derivative or antiderivative of this whole function k fx. So this k can be taken out of this integration process, and this will be k times integral of fx dx. So this also is applicable in the derivative as well as limit also. Same way we can take out the constant out of this operator of integral. Similarly, one more important theorem is that is simply the integral of sum or difference of two function is equal to the sum or difference of integral of two function. That means if integration is applied on the sum or difference of two functions, suppose they are fx and gx, their sum or difference is given and integral is applied, so integral can be distributed on both of the functions and their sum or difference can be taken. Okay, that means whether the two functions are added or subtracted, we can distribute the integral operator on both, and this way this can be useful in so many questions. So let's take one example where these theorems are applied. So various questions are given wherever you have to use this and you have to apply these questions. So for example, if it is given to you, one of the example if I take, suppose it is given to you that find the integration of sine 2x plus cos 2x dx. So how to find out the integral of this? First thing is that we are going to use this above theorem to distribute this integral in both of the parts. So when we distribute these both, so we get sine 2x dx plus integral of cos 2x dx, right? After that, we know that integral of sine 2x, if we have to find, so there is a formula, or you can do these things separately and then you can find out their sum. What is that formula? If we have this kind of integration sine ax dx, so integral of this will be your minus cos ax upon a plus c. So here, using the same concept, this sine 2x dx will give us minus cos 2x upon 2, and here also cos 2x dx will give you minus, similarly as we have for sine ax dx, this minus cos ax upon a, similarly we have the integral of cos ax dx as sine ax upon a plus c. Okay, so using this we can write down this as sine 2x upon 2, and since both are integrated and they will give you c as a constant, arbitrary constant, as integral constant, so this is going to be your result, which you can see that where you can little bit more simplify if this kind of expression you are getting. Otherwise, if you are leaving here also, it is not wrong, but one more way you can simplify. What way you can simplify? If you write down this sine 2x this side and cos 2x this side, and you can multiply, and means you can break this 2 in this form, that means 1 upon root 2 you can take common. So this you can write as 1 upon root 2 sine 2x and minus 1 upon root 2 cos 2x, and plus c is already there. After that, here this internal bracket things, what it has been 1 upon root 2 you can write as this thing is going to be your cos pi by 4, and this is going to be your sine pi by 4. So cos a sine b minus sine a cos b, this will develop sine a minus b formula. So this will be ultimately giving you 1 upon root 2 sine 2x minus pi by 4 and plus c. So this is going to be finally the integral of this sine 2x plus cos 2x, right? Okay, let's see one last example. Sec x into sec x plus tan x dx. If we have to find out the integral of this, so first we have to multiply this sec x into this to open this bracket, and we get here sec square x plus sec x tan x dx. Now by using the theorem, we distribute the integral in both of these parts, so it will be integral of sec square x dx plus integration of sec x tan x dx. Then we know that whose derivative you have learned as sec square x. If you remember from differentiation, so sec square x was derivative of tan x. Okay, so that's why sec square x antiderivative will be your tan x. Antiderivative means integral of sec square x, that is your tan x. Similarly, here sec x tan x, this much part you have already seen that this was the derivative of which function? If you remember, if you recall, so you know that sec x derivative was sec x tan x. That means antiderivative of sec x tan x will be your sec x only. And plus c we add as arbitrary constant after integration. So that's it. It is your answer for this integral of this given function. So this way there are so many questions which you can solve and practice. And next video we develop for various other methods of integration where you need to practice and look for various examples to develop the better understanding of integration. So thank you all.